Hello everyone, my name is Sonali Mari and today I'm here to present my presentation on the topic loss functions. So let's begin. So basically a loss function is one of the most important components of any machine learning or deep learning model. It acts as a mathematical tool that measures how far the model's predictions are from the actual values. So during training, our goal is to minimize this loss, meaning we want our predictions to be as accurate as possible. So the model learns through optimization algorithms like gradient descent, which adjust the internal weights based on the loss value. The smaller the loss, the better the model's performance and ability to generalize to new data. So, in simple words, we can say that the loss function provides a clear quantitative signal that guides the model's learning process. Without it, neural networks would have no way of knowing whether their predictions are right or wrong. So, now understanding what exactly the concept of loss functions is, it serves as a bridge between prediction and optimization. It measures the error and provides feedback to update the model's weights. Broadly, there are two major types of loss functions. Those are regression losses, which are used for continuous outputs, which includes mean squared error, mean absolute error, and Huber loss. And the classification losses on the other side deals with categorical outputs, which includes the examples such as cross entropy loss, hinge loss, and KL divergence. So basically, the choice of loss function plays a major role in determining the stability, convergence, speed, and overall accuracy of the training. Sometimes custom loss functions are designed for unique data patterns. For example, negative log likelihood is used in probabilistic methods. The right choice of loss function helps the model to learn effectively and efficiently there. So now let us understand what exactly the working mechanism is. The model receives input data and generates predictions. The loss functions then calculates the difference between these predicted and actual values. The calculated loss is used to compute gradients for each model parameters. Through back propagation, these gradients are sent backward through the network. The optimizer, for example, stochastic gradient descent or ADAM, uses these gradients to update the model weights in the direction that reduces the Huber loss. Over several epochs, this iterative process helps the model to gradually minimize its loss and improve its accuracy. Eventually, the model converges at an optimal point where the loss is minimal, meaning it has learned the best possible parameters for that particular given data. So basically, the mathematical representation is given as L over y comma y hat equals to 1 upon n summation n over I is equal to 1 in the square brackets yi minus yi hat square. This process repeats until the model reaches an optimal solution, which is generally referred as the convergence. So now let us understand what exactly the challenges are there in implementing the loss functions. The model receives input data and generates predictions. The loss function then calculates the difference between these predicted and actual values. This calculated loss is used to compute gradient for each model parameter. Through back propagation, these gradients are sent backward through the network. For example, the optimizer. So, stochastic gradient descent or ADAM uses these gradients to update the model weights in the direction that reduces the loss. Over several epochs, this iterative process helps the model to gradually minimize its loss and improve its accuracy. Eventually, the model converges at an optimal point where the loss is minimal, meaning it has learned the best possible parameters for the given data. So now let us move towards what exactly the summary of this particular point is. So to summarize, the loss function plays a central role in the learning and optimization of deep learning models. It acts as a numerical feedback system that guides how a model improves during training. Different problems require different loss functions. So, there are no universal one particular loss function that fits the all cases. Understanding all of the mathematical behavior which helps us to avoid issues like instability or poor convergence. When designed and turned properly, loss functions ensure faster convergence, better generalization, and more accurate predictions. In a sense, loss functions are the compass of every learning algorithm, directing it towards intelligence and precision. So, this was the particular point. Thank you for giving me this opportunity. Thank you so much.